Hey, what's up, YouTube? Thanks for tuning in to part 2 of our genetics crash course. Again, these brand new ones may supersede any previous information you heard. They may kind of dovetail with a lot of the things I said in earlier podcasts and broadcasts, maybe several years ago with my Genetics 101 vid. But right now we're going to look at something cool. We were talking about last time the expression in a codominant fashion, a true codom, meaning two separate traits that can express at the same time that affect the look of an organism. And in that particular case, we were talking about primarily the trait anaconda or superconda, and the fact that an albino gene could cause the belly to express yellow. Now, some of those yellows that we saw in a lot of those early pairings did everything from a yellow that went from the chin all the way to the vent. There were yellows that expressed even subcaudally. That just means the underside of the tail. That would be the belly past the cloaca. We even saw, yellow down there a lot of times that would mottle. Sometimes the side walls were broken. Sometimes they were jagged. It was just all kinds of stuff. And then other traits were crossed into anacondas like the shadow. And if you saw my shadow morph crash course, you saw that sometimes there's little ridges that go in and out along the side walls. So a lot of things began to affect something that was fairly consistent in a trait that we would consider dominant. It was incomplete dominant, but you understand the point. So different genes, we call them polygenes, can affect form or function in an animal. The negative side of it, we've talked about in other vids, is seeing just different negative traits that express that are sometimes related. You get two copies of it, you get a cleft palate. You get two copies, you get some type of a missing tail tip or a missing eye or both eyes missing. Something is always present, especially with those recessive ones. And then there's other ones that act in a dominant fashion where you can even have negative traits that express every single generation. And those are the animals that we should consider removing from the breeding pool. Some people won't because they're just in it for the buck. But other people, if they see that come and go, you know what, I'll keep him, Herbert the lavender with a stubtail over here to the side. He won't breed. He'll just be my pet. I'll show him off. We love him. But we understand that the genetic inheritance there can affect future progeny. And you definitely don't want to put that out into the market because it just doesn't help things long term. Other people have to pull animals out. And if you can be the one that kind of makes change for the future, it's always a huge benefit. So of interest, I've heard at least recently that there are genes that require two copies present to basically affect a third gene for expression, and this is in ball pythons. I'm not familiar with that exactly. You may know and want to drop it in the comments below. I think in talking to a ball python breeder friend, it had to do with the desert ghost. But basically, these are the new terms or the new things that we should be on the lookout for, even in the hognose world. Sometimes they may not follow the typical path of inheritance. They may not follow the typical path of dominance where something is expressed first generation. There may be other factors that we have to look into, like dilution. Sometimes the expression of animals is diluted because the lines that we mix in. Look at Super Arctic, for example. A lot of times when you cross really rich reds, background coloration reds into them, it alters it by making it become pink. So it affects the dominance or the expression of an animal. Sometimes we consider these to be enhancer morphs. So an enhancer morph would make something really look sharp, really look cool. It would change the overall look. So lots of genes in that polygenetic or polygene category that we can kind of start honing in on, especially right now in old-fashioned style with just doing test crosses. That's all we have to look at until we have satisfactory and affordable, let's face it, different types of genetic studies we can do with the hognose to determine what types of traits they are and what can be expressed. So sky is still the limit. I think it's a good place to be in the hognose hobby. I love the ball python hobby just because there are so many different traits. I don't keep any ball pythons, but I just love looking into it because I love the genetics of it. They're just entirely variable, but so is the hognose. But I still think we have a lot to do yet, and we have a lot to see about crossing different hognose snakes. We're going to go ahead and wrap it up there, guys. Thanks for the like and subscribe, and as always, I will catch you on the flip side.